Second sum please. X of n is equal to minus a raised to n u of minus n minus 1. Okay, you have to find the z transform. This is the second standard signal please. Okay. Now, what is the meaning of this u of minus n minus 1? What all operations? N minus 1 is the delay operation, right shift, and then you will have a fold. Okay, so delay and fold. So let me just plot u of minus n minus 1 for your understanding. So first operation is, I will say u of n minus 1. What is u of n minus 1? U of n minus 1 is like this. It starts over here, 1, 2, 3, 4, 5. Okay, this is my u of n minus 1. Shifted step, right? Next is u of minus n minus 1. So this was delay operation. Next is a fold. Okay, so we will just fold the signal. So folding, what happens when you fold this? You will have 1, 2, 3, 4, 5, and so on. Okay, this is also so on. So it starts from minus 1, minus 2, minus 3, minus 4, minus 5, and so on. Fine. So what is u of minus n minus 1? It means that the signal starts from n is equal to minus 1 and goes up to n is equal to minus infinity. Okay. Therefore, I can just write over here, therefore, x of n I can write just for understanding minus a raised to n for what values of n? N less than or equal to minus 1. Fine. So, this signal over here will exist only for values of n less than equal to minus 1. Fine. Okay. Now, how is the plot of this? Okay. I will just plot x of n. You can do it yourself also. So, this signal will exist from minus 1, minus 2, minus 3, minus 4, and so on. Okay. If I take value of a more than 1, okay, I will get maybe a graph like this. A of minus 1, A of minus 2, A of minus 3, A of minus 4, and so on. Okay, so this is for value A is less than 1. So if A is less than 1, you will get this kind of a graph. Okay, I mean mod A is less than 1, you will get this kind of a graph. Right? So this is a increasing signal, so it is an unstable signal. When will it be stable? Stable if mod A is more than 1. So the graph for that will be in this format, just for your understanding. Something of this sort. Right? So not relevant for us at the moment. We'll just deal with this signal. Alright. Let us now find the Z transform of this. Right. So your x of n is equal to minus a raised to n, we have seen, for n more than less than equal to 1. Therefore, I will say minus 1, x of z is equal to summation n is equal to minus infinity x of n z raised to minus n. Okay, where does x of n exist from? From minus 1 to minus infinity. So, it is going to be summation n is equal to minus 1 to minus infinity x of n z raised to minus n. Okay. Value of x of n is minus a raised to n z of minus n. Let us put okay, how do you solve this? Okay, how do you solve this? Let us put minus n is equal to m. Alright. Therefore, n is equal to minus m. Therefore, I will have x of z is equal to summation minus m is equal to minus 1 and minus m is equal to minus infinity minus a n is minus m and z is m. Therefore, I will say x of z is equal to summation m is equal to 1 to m is equal to infinity minus of A inverse Z raised to M. Just check this out. Okay, minus outside A raised to minus 1 into Z the whole into M. So we will get back this thing. Fine. So therefore you can say summation M is equal to 1 to infinity minus of A inverse Z M. Okay. So the basic value over here, first value is, let us put M is equal to 1 to infinity. Let us put the value of M is equal to 1 plus 1, please. Summation is minus, I'll put the minus outside. Value of M is 1, first value of M is 1. So A inverse Z plus, then you will have M as 2, the next value is, so A inverse Z the whole square plus next value of M is 3, A inverse Z the whole cube plus so on. Okay. So now you can take A inverse Z outside if you want. So I will have 1 plus A inverse Z plus A inverse Z the whole square plus so on. So the answer of this is minus A inverse Z. This is the sum. Progression please. 1 upon 1 minus A inverse Z. Fine. Therefore, you can say therefore x of Z is equal to minus A inverse Z upon 1 minus A inverse Z. Therefore, you can write like this. Therefore, x of Z is equal to minus of A inverse Z upon 1 minus A inverse Z. That is minus Z upon A, 1 minus Z upon A. So this is going to be, A will be cut, so you will have minus Z upon A minus Z. Therefore, you can say x of Z is equal to Z upon Z minus A. Fine. So, what do you say? Therefore, my sum was minus A raised to N U of minus N minus 1. The Z transform is minus A raised to 1 minus 1 Z upon 1 minus A raised to minus 1 Z is same as equal to Z upon Z minus A. So, this is my answer. This is my second standard signal. Let us talk about the ROC also. To get this equation, my A inverse Z should be less than 1. Okay, A should be less than 1, right? So, A inverse Z should be less than 1. Therefore, Z upon A should be less than 1. Therefore, mod of Z should be less than mod of A. Fine. So, this is the ROC. So, ROC is mod of Z should be less than mod of A. So, the ROC is mod of Z should be less than mod of A. Let us draw the ROC over here. So, I have a unit circle. Okay. It is my Z transform is Z upon Z minus A. So, the pole is Z is equal to A. Fine. So, if I say if mod A is less than 1, if I say like this, if I say my A is over here, so I have a pole over here. Similarly, use the other case also, right? I can say over here the case is mod A is more than A, so A should be somewhere outside. Alright. So for these two conditions, I need to plot my ROC. What is my ROC saying? ROC is mod Z is less than mod A. What is mod Z? I have said it is a circle that is less than A, radius is less than A. So a circle which is inwards, right? So this is your mod Z is less than mod A. Over here, what is your ROC? Mod Z is less than mod A, right? So mod Z is a circle, it's inwards. Mod Z is less than mod A, so it's a circle is inwards. Fine. So this is also a mod Z is less than mod A. Alright. So mod Z is less than mod A is the ROC, and we get the ROC for two conditions of A like this. Is it okay? Yeah. So what do we learn? What is our conclusion? What is to be remembered? That is the important thing. First is a raised to n u of n, the z transform. What is to be known? This is very important. One page is important. This is a conclusion of whatever we have done. Is 1 upon 1 minus a z inverse is equal to z upon z minus a. What is ROC over here? Mod z greater than mod a. And next thing, minus a raised to n u of minus n minus 1. इसका z transform is minus a raised to minus 1 z upon 1 minus a z inverse. If you can't remember this, just remember this thing, z upon z minus a. Okay, here mod z is less than mod a. Mod z is less than mod a. Alright, so how do you remember this thing? What is u of n? U of n is a right-sided signal. So whenever you have u of n, my ROC is more than, same way as you have seen for your Laplace transform also, sigma was more than a, right? That way, that kind of a thing. And what is u of minus n minus 1? It's a left-sided signal. So left-sided signal will have ROC less than. So sigma, like sigma less than a, right? We had seen this for Laplace transform. For Laplace transform, we had seen this, right? Okay. So this is to be remembered. This page is very important to remember. This is your standard signal. And as we had seen, always delta t, right? Delta t. Impulse z transform is always 1. Okay. And ROC is entire z plane. Okay, entire z plane. What does it mean by entire z plane? If this is your z plane, unit circle, entire z plane means the entire region. Okay. This is your entire z plane. Good. So these three are the standard signals. Please remember this and keep. We will require this for our sums. Let's start with properties of ROC. Alright. You can say final ROC is intersection of individual ROCs. For example, if you want to know that, if mod z is more than 2 and mod z is more than 3, okay. So what is the ROC for this? I will draw a unit circle. Always whenever you start with ROCs, draw the unit circle. Where is 2? 2 must be somewhere over here. 3 is over here. Okay. So what is mod z is more than 2? Mod z is more than 2 means you must not include the pole, okay. So this is your mod z is more than 2. This is 2, okay. What is mod z is more than 3? Mod z is more than 3 means this. Okay. So what is the final ROC for this? It is the intersection of the black and the green lines. That means it is this. Alright, so what is the intersection of, what is the final ROC for this? Mod z is more than mod 3. So final ROC is the intersection of both the ROCs. Right? Just an example over here. Next property please. ROC does not contain poles. Alright, so we have seen the example for this also. Unit circle over here. If I say mod z is more than 2, I must not include this pole. Okay, so I must draw the ROC like this. I must not, the ROC should not include. So the ROC is these hashed lines. This ROC should not include the pole. Why is that? For example, if my Z transform for this was z upon z minus 2. What happens if I include the pole also? If I include the pole, what is ROC basically? We have seen Laplace. ROC means the entire region at which Z transform exists, right? So, if I include if I include the pole for this Z transform, that is, if Z is equal to 2, what happens if Z is equal to Z upon 2 minus 2? That is Z upon Z, that is infinite, right? So, what happens at Z is equal to 2, my x of Z is infinite, that is, it is not defined. That is, it does not exist. So, my ROC, if my ROC contains the pole, then the Z transform will not exist. So, what is ROC? Just for your understanding once again, ROC means the entire region at which a Z transform or Laplace transform exists. If in that ROC there is a pole, then Z transform will not exist in that case. Alright. So, very important thing to understand, the ROC should not contain any pole. Okay. Third property, please. If signal is finite duration, ROC is the entire Z plane. Okay. And what is the meaning of this? If signal is finite duration, the ROC is entire Z plane. Means if x of n, if I say is 1, 2, 3, 4. What is 1, 2, 3, 4? It's a finite duration, right? Finite duration signal. So, any signal like this, x of n is 1, 2, 3, 4. If it is finite, then what can I say? I can say that the Z transform, ROC, is the entire Z plane. Means, if this is my Z plane with radius 1 unit circle, then the ROC is the entire Z plane. What is the meaning of an infinite signal? So, for example, if a raised to n, right, u of n, yeah, it always, it keep, the graph is like this, right, a raised to n u of n. It's an infinite duration signal. That is why the ROC is not the entire Z plane. The ROC is some defined value, right? We had seen, we have like this, right, something like this. Not the entire, it is some specific ROC. Fine. So, if you have an infinite signal like a raised to n u of n, you will have you will not have the entire Z plane as the ROC. But if you have a finite duration signal, 1, 2, 3, 4, it's finite duration, okay, you only have 1, 2, 3, 4. This x of n, 0, 1, 2, 3. If it is a finite duration signal, then you will have the entire Z plane as the ROC. Okay. Next property of Z transform. These properties come in your exam as a short note. So, just remember this. Next property is, if ROC contains the unit circle, then the system or signal is stable. Very important. If ROC does not contain unit circle, then system or signal is unstable. So, how did you know this? For example, I have a thing like this. I have my unit circle. If I draw a pole, if I say ROC is mod Z is more than half. Okay. So, where is my pole? Pole is like this, half over here. How is my ROC? ROC is like this. What is black circle? Black circle is my unit circle, okay, with radius 1. So, this ROC, it contains the unit circle. So, I can say that whatever is the signal, that signal is stable. And we will learn more on this when we see of causality and stability. Okay. Next property you can say as, we will see more on this when we see causality and stability. If ROC is right of rightmost pole, then signal is right sided. If ROC is left of leftmost pole, then signal is left sided. And you can say if ROC is in between two poles, then signal is both sided. Okay, both sided means, what is the meaning of right sided? Signal will start from 0. Okay, right sided. Left sided means signal will start from 0 to minus infinity, here till plus infinity. Both sided means signal will be there on both the sides, okay. Both the right and the left hand side. Fine, we'll learn both of this when we see causality and stability of Z transform. Fine. So we have finished off with the formula, we have finished off with the standard signals, and now this is finishing off with properties of ROCs.